Welcome to another deep dive.
Yeah.
We're going to try to pack a whole lot into this one. We're tackling management information systems.
MIS.
MIS, yeah.
Yeah.
You've given us a really thorough study guide and fact sheet here. And I think it's going to be really interesting to
Yeah.
sort of unpack it all and get to the core of what MIS is all about.
Definitely.
For our listeners who maybe aren't as familiar with this, we're going to go all the way from its history to all the components.
Right.
And, how it's shaping business decisions today.
Absolutely.
So this isn't going to be like, a dry college lecture or anything. We're going to keep it light and fun.
Yeah.
But, hit those key insights that'll give you a solid understanding of MIS.
Yeah.
So MIS often seems like a super modern concept, but I'm curious, where does it all begin? I mean, where do we sketch this story?
Well, you might be surprised to learn that the roots of MIS actually stretch back centuries. Yeah. While we often think of smartphones and laptops as the tools of today, people have actually been finding ways to compute and process information for a long, long time.
That's true. I mean, I guess you think about something as simple as an abacus being used to keep track of finances,
Yeah.
way back in the day.
Yeah, exactly. The abacus, invented around 2300 BC, is a great example of that.
Wow.
It was a revolutionary tool for its time,
Yeah.
allowing people to perform calculations much faster than they could do mentally.
I can only imagine.
And then fast forward to the 17th century, we have the slide rule.
Oh, yeah, the slide rule.
Yeah. This tool was essential for engineers and scientists for centuries. It simplified really complex calculations.
I remember seeing those in old movies and stuff. I mean, can you imagine? It must have been so game-changing.
Oh, it was. It was a major leap forward.
Yes.
But then, just as the slide rule had kind of replaced earlier tools, the pocket calculator came along.
Oh, right, yeah.
And disrupted everything.
It seems like a theme, right?
It is. It is. It's a classic example of how technology constantly evolves.
Yeah.
And makes often previous tools obsolete.
Which makes me think about, you mentioned the pocket calculator, but even before that, the ENIS, that massive room-sized computer.
Right.
It's just mind-blowing to think that something that big was considered cutting-edge technology.
It is remarkable, isn't it? The ENIAC could perform more calculations than, all of humankind had done up to that point. But today, that same computing power fits in your pocket.
I know. It's insane.
It really is. And, this rapid pace of advancement is largely driven by Moore's law, which states that the number of transistors on an integrated circuit doubles roughly every 2 years.
Wow.
So it's this exponential growth that's fueled the incredible miniaturization and power of the devices we use today.
So we've got all this incredible hardware, but what good is a powerful machine without instructions? Right?
Yeah.
That's where software comes in, I guess. To tell the hardware what to do.
Software is the set of instructions that tell the hardware what to do. It's essentially the brains of the operation.
Okay.
And just like hardware, software also has its own fascinating history and evolution.
I've heard about early programming languages.
Yeah.
Requiring code to be hand converted into binary. That sounds incredibly tedious.
Oh, it was. It was incredibly complex. Early languages were very machine-oriented,
Yeah.
requiring a deep understanding of computer architecture. But then came languages like COBOL, which was designed specifically for business applications.
COBOL.
Yeah, and it used English-like syntax, which made it much easier for programmers to write and understand code.
So it's kind of bridging the gap between the really technical and the practical needs of businesses.
Exactly. And then you have languages like C, C++, plus Java, and Python.
Oh, yeah. More familiar names.
Yeah. And each of these kind of built on the foundations laid by earlier languages.
It sounds like a family tree, almost,
It really is.
of languages,
Yeah.
building upon one another.
That's a great analogy.
But even with all this powerful hardware and sophisticated software, they're kind of useless if they can't communicate, right?
Absolutely.
Which brings us to networks, I suppose.
This brings us to the world of telecommunications and networks.
Okay.
And the way devices communicate and the challenges of keeping that communication secure is a crucial aspect of MIS.
It's interesting to think about everything from online shopping to, the global financial markets.
Right.
All depends on secure networks.
Absolutely. And, just choosing the right tool for a job, selecting the right network topology is really crucial.
Okay.
We have different types, like point-to-point, bus, star, ring, and mesh, each with their own strengths and weaknesses depending on the application.
So what about the internet?
Yeah.
What kind of network would that be considered?
The internet is a great example of a mesh network, meaning it has multiple redundant connections that makes it incredibly resilient, difficult to disrupt.
So that's why, like, people think of the internet as being virtually indestructible.
Pretty much. But even with this robust structure, there are still concerns.
Right.
Things like hacking and data breaches are still major issues.
And with so much data being transmitted, security must be like a top priority.
Absolutely.
Yeah.
That's where understanding something called the CIA triad becomes essential.
Okay.
It stands for confidentiality, integrity, and availability. And it really forms the foundation of information security.
So confidentiality would be like keeping information private.
Right.
Integrity is making sure that data is not tampered with.
Yes.
And availability means that authorized users can access the information when they need it.
Exactly. It's all about protecting information.
Sure.
From unauthorized access, modification, and disruption.
So are there like different ways that data can be lost or compromised?
Yeah.
Like what are the main categories?
You have unauthorized disclosure,
Okay.
incorrect modification, faulty service,
Yeah.
denial of service, and infrastructure loss. Each of these poses a significant threat to businesses and individuals.
So it seems like, as technology is advanced, there's also this kind of corresponding challenge to keep information secure.
It's a constant push and pull.
Yeah.
The world of MIS is very dynamic.
It's fascinating, though. I'm starting to see how all these pieces kind of fit together, but I'm curious, how do businesses actually leverage all this technology, to make decisions and gain a competitive edge? What does that look like in practice?
That's a great question, and it really leads us to the heart of how MIS impacts businesses. So let's talk about business information systems.
Okay, let's do it. So business information systems, this is where it all comes together to make a real impact, right?
Exactly. And one of the most transformative areas we've seen is e-commerce.
Yeah, e-commerce has completely changed the game, hasn't it?
Oh, absolutely. It's created a whole new way for businesses to connect with customers and for businesses to connect with each other. We've seen a huge shift from traditional brick and mortar stores to online marketplaces. It's pretty remarkable.
It's true. I mean, it seems like every business these days has to have some sort of online presence.
It's almost unavoidable at this point. And technology has really enabled this shift by making it possible to create all sorts of different e-commerce models.
Like, what are some examples?
Well, the one we're probably all most familiar with is business to consumer, B2C.
Right.
Like when you buy something from Amazon or order takeout through an app.
Okay, so that's B2C. What else is there?
You also have business to business, B2B, where businesses are transacting with each other.
So like a manufacturer selling parts to a distributor.
Exactly. Or a software company providing services to another business.
I see. What about those platforms where people sell stuff to each other directly, like eBay or Etsy?
That's consumer to consumer, C2C. It's another big piece of the e-commerce landscape.
Okay, so we've got B2C, B2B, and C2C. Is there anything else?
One more, and it's a bit less obvious. Consumer to business, or C2B. This is where individuals provide value to businesses.
Like freelance writers or designers?
Perfect examples. It's amazing how technology has enabled these various ways of doing business.
It really is. And it just seems like it's constantly evolving, doesn't it? I mean, what even existed 10 years ago that we take for granted now?
Right. That's a key point. Bell's law highlights this constant evolution.
Okay.
It states that new classes of technology emerge every decade, leading to the creation of, entirely new industries. Self-driving cars, widespread cryptocurrency use things we could barely imagine just a few years ago.
That is mind-boggling when you really stop to think about it. It's like we're living in the future.
In a way, we are. And speaking of things that grow rapidly, think about how the value of a network increases as more people use it.
Like social media.
Exactly. Metcalfe's law explains this. The more users join a network, the more valuable it becomes. It's like a snowball effect.
That's so true. The more people are using a platform, the more attractive it becomes to even more users.
Precisely. And all of this is powered by, you guessed it, data.
Data, it's the foundation of everything these days.
It really is the lifeblood of informed decision-making. Without data, businesses are just guessing.
Right. But managing all that data, making sure it's organized and accessible, that's got to be a huge challenge.
It can be, which is why we have data models. They act as blueprints, helping us understand and organize the vast amounts of data we collect.
So data models are like the instruction manuals for data.
That's a good way to think about it. You need to know what data you have, how it's structured, and where it's stored. And that's where database management systems, DBMS, come into play.
Okay, so DBMS is like the software that runs the whole database.
Exactly. It's the control center for your data. It lets you create, process, and administer databases, ensuring that your data is accurate, secure, and accessible to those who need it.
Got it. And are there different types of databases?
There are. But the most common type is a relational database, which organizes data into tables, kind of like a really advanced spreadsheet.
So it's all neatly arranged in rows and columns.
Precisely. And the fact that data storage has become so much cheaper and accessible is a big reason why we see so much data being collected and used.
Yeah, that makes sense. I remember when floppy disks were the standard. Now we have cloud solutions that seem almost limitless.
That shift is largely due to Kreider's law. It basically states that the cost of data storage decreases exponentially over time. This is why cloud solutions like Amazon Web Services and Microsoft Azure have become so popular.
Okay, so we've got all this data being stored, but how do businesses actually extract meaningful insights from it?
That's where data mining comes in.
Data mining.
It involves using techniques from statistics and artificial intelligence to discover hidden patterns and trends in data. It's like sifting through a mountain of sand to find those little nuggets of gold.
So you're looking for those valuable insights that can help a business make better decisions.
Precisely. You can use it for prediction, classification, identification, optimization. It's a powerful tool.
Can you give me an example of how a business might use data mining?
Sure. Imagine a retail company wants to understand customer buying behavior. They could use data mining to analyze their sales data and maybe discover that customers who buy a certain type of shoe are also likely to buy a particular brand of socks.
Interesting.
Right. Then they could use that information to target their marketing efforts more effectively, maybe even offer special promotions bundling those items together.
That's a great example. So we've talked about collecting data, storing it, organizing it, and then extracting those insights. But how do businesses actually put all this knowledge into action?
Right.
How do they turn those insights into real-world results?
That's where project management comes in, and that's a whole other fascinating aspect of MIS.
Project management. Okay, so we're talking about the art of taking those data-driven insights and actually implementing them.
You got it. It's about turning plans into reality, and it's something that has a long and fascinating history. I mean, think about it. Ancient civilizations built marvels like the pyramids and the Great Wall of China without any of the formal project management frameworks we have today.
That's mind-blowing. I can't even imagine the logistical challenges they must have faced.
I know, it's incredible to think about. But even in more recent times, project management has gone through some major transformations. For example, Henry Gant's invention of the Gantt chart back in 1917 was a game changer.
Oh, Gantt charts. I've definitely seen those before, those bar charts that show project timelines.
That's right. They provide a visual representation of the project, making it easier to track progress and identify potential delays. And then after World War II, we saw even more sophisticated approaches like PERT and CPM emerge. They used mathematical models to analyze and schedule project activities.
It's amazing how far project management has come.
It really has. And today we have such a wide range of approaches and tools to choose from depending on the project and the organization. We have the traditional waterfall method, which is very linear and sequential. And then we have Agile, which is much more iterative and flexible. There are also tools like Kanban boards, Scrum frameworks, and the Scaled Agile framework, or SAFe, for managing really complex projects across large organizations.
I've heard some of those terms before, but honestly, I'm not really familiar with most of them. What are some of the most important concepts in project management that everyone should know?
Well, understanding the triple constraint is crucial.
The triple constraint.
It refers to the three key factors that constrain any project: scope, time, and cost. You can't change one without impacting the others. It's all about finding the right balance.
I see. So you have to carefully consider the trade-offs. What else?
Another key concept is the critical path. This is the sequence of tasks that determines the shortest possible duration of the project.
So it's like figuring out the most efficient route to get from the start to the finish line.
Precisely. And then there's the work breakdown structure, or WBS, which involves breaking down the entire project into smaller, more manageable tasks.
It seems like project management is all about finding ways to make complex things more manageable.
That's a great way to put it. And by effectively breaking down a project into smaller components, you can ensure that it's completed on time, within budget, and to the required specifications.
This is all really interesting. So we've explored data, Databases and the complexities of project management. Is there anything else we need to consider when it comes to MIS?
There's one more crucial aspect that we can't overlook. It's something that's becoming increasingly important as technology plays a larger role in our lives, and that's the ethical and legal implications of MIS.
Ethical and legal implications. That's a big one. I mean, we've seen the consequences when technology is misused. Data breaches, privacy violations. It feels like that's always in the headlines these days.
It's definitely an area that we can't afford to ignore, especially as technology becomes even more integrated into our lives.
So where do we even begin? What are the main things to consider when we're talking about the ethics of using information systems?
Well, one of the most fundamental principles is information security. It's about protecting sensitive information from a whole range of threats, from unauthorized access and misuse to disclosure, disruption, modification, or even destruction.
So it's not just about, like, keeping hackers out.
That's a big part of it, of course, but it's also about making sure that information is used responsibly, accurately, and in a way that respects people's privacy.
I see. So we're talking about both intentional threats, like cyber attacks, and unintentional threats, like just human error.
Exactly. We need to address both sides of the equation.
It's true. We all make mistakes. And sometimes those mistakes can have pretty serious consequences, especially when we're dealing with sensitive information.
Think about it. Accidentally emailing a confidential file to the wrong person, leaving a laptop with sensitive data unlocked. Those kinds of things can happen to anyone.
That's why it's so important for organizations to have those strong security policies and training programs in place, right?
Absolutely. Educating employees about best practices, things like recognizing phishing scams, creating strong passwords, and handling data responsibly, those are all key steps. But even with the best training and policies, we still have to face the reality of deliberate cyber attacks.
It seems like those are becoming more common, or at least we hear about them more often. It's a bit scary, to be honest.
It's definitely a major concern, and hackers are becoming more and more sophisticated in their methods. Organizations really need to invest in robust security measures like firewalls, intrusion detection systems, encryption technologies, things like that.
So it's a constant arms race, basically.
In a way, yes. You have to stay one step ahead of the bad guys. And then there's the whole other category of threats, those that are completely outside of our control. Natural disasters.
Right. Floods, fires, earthquakes. Those can be devastating.
Absolutely. They can damage equipment, disrupt operations, lead to data loss and downtime. That's why having a solid disaster recovery plan is essential. You have to be prepared for the unexpected.
It's funny how we often think of technology as being so durable, but in reality, it's pretty fragile.
That's a great point, and I think it highlights something really important. Technology is only as good as the people who manage and use it, which brings us back to that idea of ethics and responsibility in MIS.
Okay, so let's dig a little deeper into that. What are some of the key things to think about in terms of ethics for MIS professionals?
Well, there are several professional organizations like the Association for Computing Machinery, ACM, the Institute of Electrical and Electronics Engineers, IEE, and the Association of Information Technology Professionals, AITP, that have developed codes of ethics to help guide professionals in the field.
So they provide a framework for making ethical decisions.
Exactly. These codes emphasize values like honesty, integrity, responsibility, fairness, respect for others, those kinds of fundamental principles.
So it's really about using this powerful technology for good and not for harm.
That's a great way to put it. MIS professionals have a responsibility to use their skills and knowledge in a way that benefits society, not just their own personal gain or the interests of their organization. They need to be mindful of the potential impact of their work and make sure that their actions are ethically sound.
That makes a lot of sense. But ethical considerations are only one part of the equation. We also have to consider the legal side of things.
Right. There's a whole network of laws and regulations that govern how information is collected, used, stored, and shared. And those laws can vary from country to country.
It seems like a pretty complex landscape to navigate.
It definitely can be. For example, here in the U.S., we have several laws that address specific types of data, like CUPA, HIPAA, FERPA, and GLBA.
I've heard of some of those, but I'm not exactly sure what they all cover.
It's easy to get them confused. COPAS stands for the Children's Online Privacy Protection Act. It's designed to protect the online privacy of children under the age of 13. IPAY, the Health Insurance Portability and Accountability Act, is all about protecting people's health information. FERPA, the Family Educational Rights and Privacy Act, focuses on safeguarding student education records. And GLBA, the Graham-Leach-Bliley Act, regulates how financial institutions handle consumer financial information.
So each of these laws focuses on a specific category of data. It seems like a lot for businesses to keep track of.
It is, but it's crucial for organizations to understand these regulations and make sure they're in compliance. The penalties for violations can be pretty steep.
It seems like the legal landscape surrounding data privacy is constantly shifting.
You're right. New laws are being introduced all the time, and existing laws are being updated to keep pace with technological advancements. So it's essential for MIS professionals to stay informed and up to date.
So we've got ethical considerations and legal requirements to think about. Is there anything else?
One more thing that's important to recognize is that MIS doesn't exist in a vacuum. It operates within a global context. Decisions made about information systems in one part of the world can have ripple effects across the globe.
Like the butterfly effect.
Kind of like that.
Yeah.
For instance, decisions about things like outsourcing and offshoring can have significant economic and social impacts on workforces in different countries.
So businesses need to think beyond just their own bottom line.
Absolutely. It's about finding that balance between economic efficiency and social responsibility. We need to use the power of MIS in a way that benefits everyone, not just a select few.
This has been such a fascinating deep dive. We've covered so much ground, from the very basics of computing to the ethical and global implications of information systems. I feel like I've learned a ton.
It's been a great conversation. I hope our listeners have gained a deeper understanding of just how complex and multifaceted MIS really is. It's a field that touches so many different aspects of our lives.
It really does. And as we wrap things up, I have one final question for you to ponder. Given how quickly technology is changing, what skills do you think will be most important for MIS professionals in the years to come?
That's a great question to consider. The ability to adapt, to be a lifelong learner, to think critically and solve problems creatively, to communicate effectively. These are all going to be essential. Technical skills are certainly important, but those soft skills are becoming increasingly valuable as well.
So it's not just about knowing the technology, but also understanding how to use it effectively in a complex and ever-changing world.
That's it, exactly. The future of MIS belongs to those who can combine their technical expertise with a strong understanding of the business world and a deep commitment to ethical conduct.
Well said. We hope this deep dive has been insightful and has maybe even inspired some of our listeners to explore this field further. It's certainly a dynamic and rewarding area to be a part of.
Thanks for joining us.
And that's a wrap for this episode of The Deep Dive. We'll catch you next time for another exploration of something fascinating.